All right, welcome everybody. In this video, I want to just kind of pick up our discussion. We were working with vectors. Most of the time, we'll be working not creating vectors from scratch, but we'll be kind of working with data sets that we import from elsewhere. But it's good to know, oftentimes we'll want to create vectors, we'll want to create some pattern vectors. For example, if we're creating like tick marks on an axis or something like that. So there are some useful R functions and for creating pattern vectors that I want to just discuss. And so if we want to create a vector of all integers that go from integer A up to n including integer B, then there are, of course, multiple ways that we can do this. One nice way to do this is to use a colon. So if I want to create all a vector of integers from, for example, 5, including 5 up to and including, say, 11, then I can do 5 colon 11. And here we have a vector of integers that go from 5, 6, 7, 8, 9, 10, and 11. And it might be interesting to think about, well, are these integers or are these decimals? So in order to do that, let me just say, I'm going to call this vec1. And let's take a look at what type is this vector. And you can see this is being stored as integers and not as decimals. Okay, so this is creating a vector of integers that start at 5 and go up to and include 11. And so this is important to note here that this is inclusive. So if you've coded in other languages, for example, Python, they might not include the 11 when you're doing similar sorts of notation, but in R, it is inclusive of both of these endpoints. So it included the 5 in the vector and it included the right endpoint 11 in the vector. So this includes all of these integers. We could have also used the sequence function to create a similar vector, but the sequence function we can customize to create all sorts of similar looking vectors that are not just integers, but also decimals. So if I want to create, for example, a vector that starts from any number, doesn't need to be an integer, that goes up to any other number, doesn't need to be an integer, we're increasing by a fixed increment, then that's where the sequence function comes in handy. So for example, if I want to start my sequence, say, at the number 1, and I want to increase it each time by increments of 2, and I want to stop at 10. I don't want to go above 10. Then I could do something like sequence from 1 to 10 by 2. And this function has 3 inputs. So the first input is what number are you starting at? And this is inclusive. The second argument in this function is where are we terminating this vector? So we're going to stop at 10. It might not include 10 if, one of our increments doesn't perfectly stop at 10, but we're not going to keep this sequence of numbers going. Once we hit 10, that's where we would stop. And again, it is inclusive of this upper limit 10. And then the third argument in this sequence that we have that we would include would be by what increment are we going up by. And all of these numbers, these can be integers or decimals. They don't need to be integers. I just chose integers in this case. So let's run this code cell down below and see what happens as I've entered it here. And if you're kind of curious about, there are many other options that you can include for this function sequence. And if you're curious about those options, you can always just run $sequence and you can find the help documentation for this function. I won't run it here, but you can dig much deeper into the sequence function. So when I ran this, notice it started at 1, and then the next one, it increased by 2 to 3, and then it went up by 2 again, and went up by 2, went up by 2. And it didn't go up to 10 because the next number would have been 11, which exceeded 10. And so that's why it didn't include 10. If instead I started from 2 to 10 by 2, notice here, it would have included at 10 and stopped at 10. So both of these endpoints are inclusive if it happens to stop based on the increments that we choose. If it happens to stop at the upper endpoint, it would include it. If it doesn't happen to stop at the upper endpoint, then it would just stop at the number that is, just short of that endpoint. And these names of each of these arguments from, to, and by, these are optional. So we don't need to include the name of the inputs. So if I put sequence 1, 10, 2, notice I get the same exact output as what I got up above. So it's the ordering that we enter these numbers that's really important. So the first input is where are we starting from? The second input is where are we stopping? The third input is by how much are we increasing each increment. And we don't necessarily need to include the names of those arguments. And most people probably would not include the name of those arguments just because it makes the code a little bit more concise to read. So whether or not you want to include those or not, that is up to you. This maybe makes the code a little more readable. It's a little more clear maybe what the 1 and the 10 and the 2 are doing. This is more concise code to read. So it's really up to you what you would like to do as far as when you're coding. And another common thing that you might want to do with this sequence function might be to, say, pick a bunch of evenly spaced out values between a start point and an end point. And this is really common, say, like for plotting functions or making tick marks on a graph or something like that. So for example, if I want to pick like 19 equally spaced numbers that start at 10 and end at, or excuse me, that start at 1 and end at 10, inclusive of both 1 and 10. And again, in some other languages, they might not include the endpoints in some similarly defined functions, but in R, they're inclusive of these endpoints. And here I do need to include the name of this input, because if I don't put the fact here that the 19 is corresponding to the length input, the number of values that I'm going to pick in between 1 and 10, it would assume that I'm choosing that this last input 19 would correspond to the increments, right? The by, that this is, I want to go from 1 to 10 and each number is going to increase by 19. But what I want is to pick 19 equally spaced values between 1 and 10. So I need to say that this 19 is not by how much I'm incrementing each number, but the number of values that I'm choosing between 1 and 10. So I need to specify here, it's not optional. I need to specifically tell R that this input 19 is corresponding to the input for the LEN, for the number of values that we're picking between 1 and 10. And so now we can count up that this has picked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 values are in my vector. Started at 1, went up to 10. These are equally spaced, meaning each value is, equally spaced out, a unit of 1, half of a unit to the next one. If I wanted to pick, 23 equally spaced out values, it's not going to be as nice of an increment, right? But now my vector has 23 values and they're all equally spaced out. If I wanted to pick 33 equally spaced out values, it would look something like that, and so on. So that's how another option that you can put in the sequence function. Okay, so there's some other information about creating some other vectors with patterns. I'll let you read the kind of that last little section, but I'll stop here for this video. Okay, thanks everybody.